Hello and welcome. In this video, we're going to interpret the regression coefficient estimates of a level-level regression. Suppose we have the following model and we wish to interpret the results. So we were saying that wage here is our dependent variable, and we're going to have education, experience, and age as our independent variables, or explanatory variables. So now suppose we've gathered our data and we've run our regression and we get the following results. Note that these results are pretty clearly completely made up, so don't take them at their face value. This kind of result right here is the typical kind of output that you'll get from an R software regression. And then kind of putting them closer into terms of the model, we get the following. So our beta 1 coefficient, the coefficient in front of education, we have is 1025. Our beta 2 coefficient we have as 560, and then our age coefficient estimate we have 235, and then our intercept here is 5,000. So how do we interpret these level-level regression results? Well, there's a few things we got to start off with just off the bat. So first off, we have to assume that our Gauss-Markov assumptions hold. These are a list of assumptions. For example, I think the first assumption is that this is actually the true model. Several other assumptions that allow us to interpret the results. If these don't hold, we might not be able to interpret the results as we're going to. The Gauss-Markov assumptions do allow for some flexibility. So, for example, if we're just trying to do kind of a rough approximation, it might be reasonable to relax the assumptions a bit. But for now, let's just assume that our Gauss-Markov assumptions completely hold. Second off, let's assume that our coefficient estimates are statistically significant and practically significant. So once again, these are completely made up numbers, but given the made up numbers, these are statistically significant. You can see our t-values are fairly large and our p-values are close to 0. And then also they need to be practically significant, right? Just because you have a coefficient result that's could be shown to be statistically significant if this estimate here is, say, close to 0 or otherwise meaningless given the typical underlying variation of a population, then it's not practically significant and we could kind of, move on. And then lastly, when we estimate any particular coefficient, so say this coefficient or this one, beta 1 or beta 2, we need to assume that we're holding the other variables constant. Okay, so giving those kind of pretty strict assumptions, what does something like beta 1 here mean? Well, to show to the fact, let's take our original model, or a version of our original model, and take the partial derivative of the independent variable with respect to the first dependent variable. So we'll do that right now. So, just kind of remember back to calculus. We have a model like this. We have y is equal to that intercept, plus some number times x1, plus some constant number times x2, plus some constant number times x3. If we wanted to find the effect on y of a change in x1, what we do is we take the first derivative of this equation with respect to x1. So that's going to be our partial derivative with respect to x1. And what we find is that the change in y over the change in x1 is going to be equal to our beta 1 coefficient. What that means is, if we were to change this by, if we were to change this equation right here by x1, what do we expect that to change? How do we expect that to change y? So if we were to change this equation right here by 1 unit of x1, we'd expect y to change by beta 1. So if we increase this model by x1, then y is going to go up by beta 1. Now, applying that to our model, with wage here as a function of education, experience, and age, we get the following. We expect, if education was increased by a single year, we expect wages to go up by $1,025. So it's the effect on this variable of a 1 unit change in this variable. So beta 1 here is if you change this education by 1, you expect wages to go up by beta 1, in this example, 1,025. So beta 1 here, if you change education by 1, we expect wages to change by beta 1. So if we increase education by 1, wages will increase by 1,025. Cool. Hopefully that's helpful. If you did find it helpful, be sure to give it a thumbs up. I'll be sure to put links in the description to more econometrics resources. Okay, thanks. Bye.